I think the first question number 1, we used to have a periodic time evaluation where a simple pendulum used to move back and forth. The periodic time is calculated as t, and they were supposed to ask what is the time taken to reach the midpoint between O and A. It is known as C. And yeah, I have just shared you the recording. You can just look at that. You must be very careful. Don't use your kinematic equation when you're trying to solve simple harmonic ones, because the velocity acceleration doesn't remain a constant. Only if the acceleration is constant, I am able to apply our kinematic equation. S is equal to ut plus half et squared. In these cases, the acceleration is either constant or it is zero. You can't have varying acceleration. So just go through the recording. I think I was explaining about the time taken for C. So let's go to question number 2. What were your answers for them? Your answers. So they have just given you that. Sorry for that. Okay. So let's look at question number 2. They have said us that a correct scale at 10 degrees Celsius, a lead measuring bar is used to measure the length of a copper rod. So you have been given with a copper rod, and there is a lead rod which is used to measure here. So this is actually like your pit ruler, okay? This is like your ruler. You are just measuring the length of him. Okay, just get that idea. And yeah, it is calibrated at 10 degrees Celsius. So if you have learned heat, can you say me what is this calibration? You have finished heat, right? I think for the first time I have included heat question. If you have finished, so you can say me what is mean by calibration? So they have just said you that the lead rod is calibrated at 10 degrees Celsius. Yeah, it's actually the temperature. The basic idea is now it's the general temperature where this ruler is made of. Okay, because when you just expose it for higher temperatures above 10, it might expand. And when you expose them to lower temperatures, it might contract. So this is the standard temperature at which this ruler is made up of. Okay, so let's get that rough idea behind them. So let's move to the question. So they are saying us a correctly scaled at 10 degrees Celsius lead measuring bar is used to measure the length of a copper rod. So this is our copper rod. And it is at 10 degrees Celsius. So the copper rod is also at the same temperature, 10 degrees Celsius. Now they are saying us the copper rod is measured to be 90 centimeter. So just think, this is your ruler. You have the 0 mark somewhere around here, and you are having the 90 centimeter mark here. Okay, The 0th mark is exact at this point. The 90 centimeter mark is exact at this point. So that is how you used to make measurements, right? This is somewhat long, okay? Clear? So I just draw a rough diagram of the first information. The calibration temperature is 10 degrees Celsius. Both are at 10 degrees Celsius. And the measurement you obtained was 90 centimeter. So if I just get your clear idea, this is your ruler, and the 0th mark of him is exact at this point, and the other part, 90 centimeter mark, is at this point. Okay? Because this will be important to deal this question, okay? So if I just went further, they are saying us, why the lead measuring bar and the copper rod are at 30 degrees Celsius temperature, find the reading of the measuring bar. Okay, find the measuring of the reading. Okay. So just say me that. Are you clear up to here? I just draw a rough diagram behind the scenario. This is like your ruler. The 0th mark is coinciding at this point, and the other end is 90 centimeter. So the length was measured to be 90 centimeter. Okay. Now, they are saying that these measurements are obtained at 30 degrees Celsius. These measurements are obtained at 30 degrees Celsius. So what can you say about the thing? So when the temperature is varied, what would happen? Yeah, of course, there will be a contraction or an expansion. And did you all get an answer for this? Did anyone get an answer? If you are obtaining an answer, just say me, okay? Yeah, this is somewhat, I just obtained this from an FWC paper. This is at what? Okay. So this is a thing to trick you, because if you try to solve them, you will just keep on moving because the amount of information is really low. So you can see that they have just given you the linear expansivity. Yeah. The linear expansivity of lead is 1.2 into 10 to the power minus 5. 1.2 into 10 to the power minus 5. The linear expansivity. And the linear expansivity of copper is 1.7 into 10 to the power minus 5. So now see here. So what you can just try here is, even not only for an MCQ or an essay, so even if it is in a past paper, just try to deal with some amount of theory. Now you can see that the linear expansivity of lead is 1.2 into 10 to the power minus 5, whereas the linear expansivity of copper is 1.7 into 10 to the power minus 5. So, we all know that generally the expression for the expansion is delta L is equal to initial length into 1 plus alpha delta theta. Sorry, it's not clear, right? Delta L is equal to 1 plus alpha delta theta into the initial length. So you should understand with the initial length, the expansion is greater. If you have a bigger length, of course, the expansion will be greater. And when you have a higher linear expansivity, again when you have a higher linear expansivity, the expansion of the rod or whatever will also be the same. Okay. If the linear expansivity is greater, the expansion would be greater, okay? For rod or whatever object, when the linear expansivity is greater, the expansion also would be greater. So just get these basic ideas. Now we are trying to take a measurement at a temperature 30 degrees Celsius. So if you look at the change in temperature, it is 30 minus 10 because initially it was at 10, both of them. Now they have been transferred to 30. So the change in temperature is 20 degrees Celsius, which is common for both of them. Both of them have the same delta theta. And if you just consider only this portion of the rods, this is a ruler, right? If you just consider only these two portions, we can almost say they are having the same length. Because now don't confuse with different lengths, okay? Because we are taking measurements. I just get you a rough idea behind them. Just think this ruler is somewhere on here. So they haven't given you an accurate idea for that also. And that's not important. For now, imagine this is our structure. So let's say we are considering only these two portions of the length. So both of them are having the same initial length. So L is also the same. But what is the significant character which is different for both of them? The natural length is the same. The change in temperature is the same. But what is different for both of them? Yeah, obviously the material is different. And yeah, did you all get this question actually? Because before I move further, I'll be up to here. This expansion, the equations and those stuff. Okay, so if so, of course the materials of both of them are different. So if the materials are different, the linear expansivities are anyways different. Okay, I'll explain that. Okay. Now what they are saying is there is a lead measuring. So there's a lead rod which is used to measure a copper rod. So it is calibrated at 10 degrees Celsius. So that's why I just mark it here. And the initial measurement is obtained at 10 degrees Celsius. So this is something like you are having a ruler and you are taking a certain measurement. Let's say you are measuring this length. This is your ruler and you are taking a measurement. So in here, you are using a lead ruler to measure a copper rod. And they are saying us when the temperature was 10, The measurement you obtained was 90 centimeter. So I just drew a scenario. You are just taking a measurement from a ruler. So of course, your ruler has a 0 mark and there will be some scales. So if this length of the copper is 90 centimeter, this part should be at 0 and this part should be at 90. That's okay, right? Because this is the basic way you just take a reading. You place at the two corners and whatever corresponding reading is obtained. So 0 is here, 90 is here. Okay. So that was, yeah, up to now we have just reached up to here. And now they are asking you that if I was obtaining a measurement at 30 degrees Celsius, what will be my reading? Will it be 90 or greater than 90 or less than that? So that's what I was saying. Now, before you just start progressing in this question, let's get a general idea. Now, usually when there is a change in temperature, there will be an expansion or a contraction. Okay. Now here there is a rise in temperature because from 10 you are measuring at 30. There is an increase in temperature. So that increase was 20 degrees Celsius, which is common for both lead and copper. Now, if I just write my expression for expansion, delta L is equal to okay. So delta L is equal to, sorry, I made a mistake. It is L into alpha delta theta. The expanded length will be 1 plus alpha delta theta. If I just consider only the expansion, it is delta L equal to L times alpha delta theta. L represents the initial length, alpha is the linear expansivity, and delta theta is your temperature. So, just think that you are just having the same length of the rod initially. So, the length of the rod is the same for both of them. And you can see the temperature change is also 20, which is common for both of them. But the material of the rods are different. So, the linear expansivity will be different. Okay. Causing a different expansion. So the expansion of both of them will be different. Okay. So I'll be up to here. Okay, fine. So just get that rough idea. The expansions will be different. And you can say that the expansion is directly proportional to the linear expansive coefficient because these are constant for both of them. Constant in the sense it is the same for both of them. So if I want to compare for both of these guys, the linear expansivity will be a factor determining the expansion. So if it is greater, the expansion will be greater. Okay. So now say me, what will happen? Out of lead and copper, who will be having the higher expansivity? They have just given you the linear expansivities. You have to determine who will have the high expansion. Yeah, right. Yeah. So you can see the values. It's 1.2 in 10 to the power minus 5. This is 1.7 in 10 to the power minus 5. So delta L of copper is greater than delta L of lead, right? So this will be an idea. The expansion of copper will be greater than the expansion of lead. So if I just draw a better diagram behind this, initially you had the 0 mark of the lead and the 90 mark of the lead somewhere on here. And you had the copper in this part. Okay. You had lead here and the copper here. Now, due to this temperature change, both of them will undergo an expansion. Both of them will undergo an expansion. And as you all say, the expansion of copper is greater than the expansion of lead. So if the 90 mark has more, okay. So this is my 90 mark. So if I just measure the expansion of lead, this 90 mark has traveled this much distance. From here it has expanded. Now see me, will copper be somewhere on here or somewhere on here? Is it A or B? Just fine, it will be B, okay? Because the expansion of copper is greater than lead. So lead has expanded until this point. So the copper should travel much more far than that. So if this was my point, the copper should travel to this point. So this will be my new diagram. Lead has expanded to some point and copper is also has expanded, but the expansion of copper is greater than lead. So this will be the final structure. The 90 mark has traveled somewhere a distance here. Okay. So I'm done with this. We will confuse the same, okay? Because as I said, you can't just simplify them and find an answer. Using your theory parts, you'll just get an answer. So is it clear or do you want me to explain this part? Yeah, this equation. This is under thermal expansions, okay? This is under thermal expansion, and you will just learn these just like an error, okay? This part, and there will be another one for a pendulum. Because with temperature, the pendulum length will increase. So the periodic time will vary. So you can also have question with that way. And the most confusing part are these ones. If they ask you the measurement, you'll be confused. Under heat, okay? So I'll play up here, this point. Because this is the most important one. Because I'm not going to do any simplification. We can find the reading directly, okay? So if you look at here again, just think this part is fixed. My 90 was here. With this temperature change, this 90 scale mark went somewhere distance here. It expanded actually. So this is my ruler. The 90 mark went up to here. So due to the temperature change, the copper also should expand. So from here, the copper would expand. And we found that the expansion of copper is greater than the expansion of lead. So from here, it will have a great expansion than this. Okay. So now say me, if I just take it as 90, you can see still some amount of copper is outside. If I just take this as my reading, it is wrong, okay? You can't say it is anymore 90. So will it be greater than or lesser than? Because you are having the 90 mark here. If I should find the reading, I should travel somewhere far. So what can you say about the reading? Will it be 90 or greater than that? Okay, now see here. This part is 90. But my copper ending point is somewhere on here. At this location. So you can see, if this is a ruler, 90 mark is here in the sense, other 91, 92, 93, so on. Anyways, you'll be having a reading greater than 90. This part is 90, but the finishing of the copper is at here. There's a small gap. So anyways, there will be a scale greater than 90. Like small lines, 90.3, whatever. But the reading will be greater than 90. If I take R is a value greater than 90. Did you get that point? Again, if you had in doubt, just ask me, okay? Okay. So if you are okay, just say me, okay? Up to here it is 90. But if I want to take a reading, it has to be like this, right? From one corner to the other corner. Then only you are obtaining a measurement. So this is my copper rod. I think it's not that clear. This is my copper rod. Up to here, it's my copper. So ending of this point and this point will get you the reading. But unfortunately, my ruler, 90 mark is somewhere on here. If I get some further readings, my final reading will be greater than 90, okay? It's 91, whatever. So the reading will be greater than 90. That's for sure. Okay, so be careful in these cases now. Even if it's a past paper, with these ideas, you can just get a rough conclusion. Then start working on problems, okay? If you have already experienced a question, then it's fine. But if it is new, you can just get these some rough ideas, okay? So if you just look at our answers, you can see 89.00. It's a reading less than 90, so you can obtain it. 89.21 is also the same. If you look at answer number 4, it is 90.01 centimeter. So that is the only reading greater than 90. So you can obviously choose that. Our answer is answer number 4. Okay. So only thing is you have to just read it well. And yeah, just get a rough idea with the expansion. His expansion would be greater. With those things, you have to just get an idea. Now we are just speaking only about this 90 centimeter mark. That's why we consider this initial length to be the same. Both of these segment are 90 centimeter in length. So that's why this L is the same. If you consider in practical, the rule is somewhat greater than that. Okay. So shall we move to the next question? Yeah. What about the answer for the third one? Did we try this question actually? I think I haven't. So let's discuss it. So this is also a bit interesting.